Just a little update on my electric bicycle plan. I had to forego the motor I already owned due to inconsistencies and incompatibilities with finding a gearbox. So I bought this motor, which has a built-in 9.7 to 1 gear reduction gearbox and runs on 24 volts. And I put my controller in a box with a pilot light and an on-off switch. And as you can see by the rheostat, I have very fine motor speed control now. You can slow this motor down to an incredibly low RPM. As such. More later. Bye. Hello fellow YouTubers. Today I'm going to be explaining how I rigged up a dual freewheel rear axle drive system for a homemade chain driven, gearbox driven bicycle. Okay, so what I have here is the normal freewheel, which normally sits on the right hand side of this threaded rear axle. Of course I got black on black here, so it's hard to see, but this is a special rear axle in that it's threaded on the other side. Now normally what you would do is there would be a thread system over here that's intended for use with a adapter to put on a rear disc brake, but instead you can simply thread on a normal single gear freewheel. However, as you might expect, there is a problem with this, and the problem is because the freewheel is driving in this direction and the threads are clockwise, the drive is anti-clockwise. This leads to the freewheel that would be used for your chain drive on the left hand side of the rear axle to want to unthread. So you have two ways around this. The first is what I adopted, and I used a permanent thread locker, glue, and after carefully cleaning the threads on the rear axle hub assembly here and on the threads inside the freewheel here, I threaded this on, applied the glue to the threads as I threaded it in, and waited a full 24 hours for the glue to harden. And believe it or not, I have been riding a bicycle with a chain driven motor similar to this. This one's only 250 watts. The one I'm using is 450 watts. Same gear ratio, 9.78 to 1. Chain driven through a small chain on this gear here to this freewheel. I've been able to drive that using a small speed controller such as this made in China and a spring-loaded hand-controlled throttle here, hooked up to the motor through this simple 3-wire connector, and this bracket, which comes with the electric motor, mounts on the rear frame of the bicycle with these saddle clamps provided. Now these are only soft aluminum, so I would stress you probably want to change these to something a little more durable, although so far I've gotten away with using these soft aluminum threaded saddle clamps around the bike frame, which mount on these two holes here, 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 and here. Sorry about the black on black production here. Anyways, if you want more information, just send me a note and I can try to explain in more detail how this works. Bye for now.
Hello YouTubers, just a further update. People still seem to be confused about how you would use an ordinary freewheel on a dual threaded rear axle hub. Allow me to explain. When you put the freewheel on the left hand side of the axle hub, it will be necessary for you to rotate the freewheel such that it locks in this direction. As you can see, if you just thread on normally, it doesn't lock. However, if you simply reverse the way you threaded it on like this. Now thread on the freewheel. You have to excuse me here, I'm trying to do this with no hands free. Now when I attempt to turn the freewheel, it locks. Just like you'd expect it to do. It's locking. It's not freewheeling. See? Locking. This is why I said you have to glue it on the axle hub shaft, because it wants to unthread the entire freewheel, so you have to glue these threads together. If it was put on this way, it threads on normally. However, when the chain goes to drive it from the engine, the electric motor, nothing happens. See? So you have to flip the freewheel over when you thread it on the axle hub, like so. And this will of course require that the threads are glued to prevent the freewheel drive. You see, now it's driving. If I hold the center, it's driving. You can hear it locking. Okay, I hope that explains it to everybody. Bye for now.
It's the same setup, except this time I'm running it on 24 volts, no load. As you can see, it's quite a bit faster. The first time I started this up, because I don't have my speed controller on, it basically torqued so heavily it pulled the motor mounts loose. So with two of these small 7.2 amp hour 12 volt batteries, this is how much speed you get under a no load. And as you can see, I'm in desperate need of a wheel balance here too, since I had to re-spoke this wheel. It's the first time I'd ever done that myself. So I have a lot of work ahead of me, but so far what I have done, for the most part, knock the wood, appears to be successful.
Hello YouTubers. Well, as you know, I build electric bikes. So what do you need to go with your electric bike but a trailer? I used a suspension joint from a car here to give me the pivoting capabilities you need, and this piece of box steel to mount it securely onto the rear axle hub. This I welded by a friend on a bent 1/2-inch steel rod, and used this 2-inch pulley with one side sawed off with a wheel cutting saw, and I have a set Allen key pin, the set Allen screw tightened on the pin to keep it in place. Then I was able to salvage two 20-inch bicycle wheels, and believe it or not, the frame base of my trailer, this white metal here, is made from aluminum tracking on a set of vertical blinds that were being thrown out. I made some axle plates here, 3-inch square, 1/4-inch mild steel, to which I anchored my two bicycle wheel axle hubs. So it's still in the build stage, but so far preliminary toe tests have proven that it seems quite adequate, and I think it'll probably be capable of holding approximately 100 pounds or 45 kilograms of cargo. The base, as you can see, is rather small. It's only comprised of about a piece of wood 2 feet by 2 feet, or 65 by 70 centimeters. But I wanted to start out with something small and manageable to see how it works. Bye for now.